do another contest. I'm doing Codeforces Division 2, number 523. I got massacred by yesterday's virtual contest, and I didn't do very good on the virtual contest before that. So hopefully today I can do a bit easier contest to, rebuild some self-confidence. Usually older Division 2 isn't very hard, but we'll see how this one is. Alright, let's see. One more minute. Hopefully I do good this contest. See, I have my writing checked up. ID1, the absolute best IDE, set up. 45 seconds. The pains of waiting. Alright, 30 more seconds, 30 more seconds. Probably gonna be something with reading an integer first. 10 seconds. 10, 9, 8, 5, 4, 3, 2, 1. Okay, finally time to start. So let's open the problem set, open the standings, and change it to friends standings, because it's very important to see the scoreboard. Alright, you have a unlimited number of coins, values 1 to n. You want to select some coins having the total value of S. What's the minimum number of coins required to get some S? Okay. Well, that should be... Alright, let's take it as two numbers, n and k. So basically, we can just take multiples of n until the last number. If k is not divisible by n, we need one more, I guess. So what? This is things like this. N k plus n minus 1 over n. Alright, that should be it, I guess. Basically, it's just the ceiling of the k divided by n. I forgot that Division 2 older ones had this stupid of problems. Alright, easy clap. You came to the exhibition, and one exhibit has drawn your attention. N stacks, AI, blah blah blah. The height of the exhibit is equal to m, consequently... Okay. We're on top. Find the maximum number of blocks you can remove such that the view for both cameras would not change. Okay, well, how does the view for the top not change? Well, if there is a block in that column originally, there has to be at least one block still. How does the right not change? Well, there has to be at least one column equal to that height. So then basically what we can do is just say, for each value that has at least 1, you'd say the sum of that minus 1, and then we have to add back the amount to make it equal to there. First two problems, pretty stupid. Let's see. Remember stacks and the height of the exhibit. Oh, I guess they're guaranteed to all be greater than 1 from the start. So let's make the sum and the maximum do y and z is the sum and maximum. And x, z into x. So y plus equals x minus 1, z max z to x. Let's do it like this, right? Then we do right minus equals z minus 1. Now we just do c out, right? Alright, hopefully that makes sense. I think I understood it right. Number of blocks. Whatever. Long. Huh? What'd I do wrong? 3, 6, 2, 4, 6, 8, 10. Okay. Well, for 1, it should be minus. The right needs at least one of, like, 3. Huh? Oh, what? Oh, I see. Alright, ret minus equals min of... Alright, you have to have both x and z. So ret minus equals max of z. Of what? Of n and z. Yeah. Some type differences. Alright, this should work. Okay, yeah. So basically, we need at least n to go all the way across, and at least the max value, which is z, to go up. And then, so you can think of, we're making a diagonal, and then whichever one is greater, we have to add a few extras. Huh. 1, 2, 3, 4, 5. What did I do wrong here? Why do I only need 1? I only remove 1. You need at least 3. 1, 2, 3. Why can't you? Oh, wait. I see. Alright. So we're gonna change up a little bit. Got a little ahead of ourselves, I guess. So instead, gonna... So first off, I'm sorting the values so that they'll be from greatest to least. And now let's see. We have to have at least 1 in each column. So how many? Alright, so let's see. Now we need to... Alright, here's my idea. Let me try it. So imagine you have the stacks in sorted order. Let's make sure my video is actually playing, unlike last time. Yeah. Okay. So, we have our stacks in, like a sorted order, right? For the first one, we know that, we'll have like this extra value, like j equal to infinity. That's an 8, infinity. So now, at the first one, we know we can take out all of the bottom ones, but we need to keep the top one. Well, okay, wait. We can take out all of them except for the ones that aren't in the one below it, right? So basically, we can take out here. And here, we can take out here. Does that make sense? I think that makes sense. That looks right. So we basically just keep the tallest one, except for at the end, we may have to keep the last one. So it should just be plus equals min. Okay. This is basically just a of I. A of I minus 1. Alright, let's see if that works. Well, I guess the right answer for that, and I'm too lazy to check for all the test cases. So let's see. Come on, hurry up. What? Well, apparently we don't even get the right answer for here, which is not very good. Alright, what do we need? Well, we can get a of I minus 1 minus 1. Min a of I minus 1. So this one we can take 2, 2, 2, 2, 2. Let's just sort them normally instead. And this is max. This one is just a of 0 minus 1. Is that right? Alright, please say this works, because this is a boring problem, and I've spent way too long on it. Oh, you gotta be kidding. What now? And why? Wait, hold on. I see. Never mind. So, okay. If this is the take out a of I minus 1. Alright, if the next one is equal to a of I, So we know that for every value, we have to take at least one. So that means let's assume we take all but the first one, a of 0, and then if, let's see, right, you're gonna have to add back, basically. So first, you're taking all but one block of each of them. However, if the last one is more than this one is not equal to this height, you're gonna have to add minus max of 0, comma, AO. J minus A of I, something like this. Why? Why are you doing this? You do what? What am I doing wrong? Alright. Should be able to take all but one. Next, you're gonna have to add back the last one. It should be min. Okay, like this. Please say this works now. This is not a strong start. Well, this looks like it's maybe right. My penalty is absolutely dead. As long as I can just get this done. Oh, you could be kidding. What now? Alright, obviously I'm just doing something stupid. Alright, first up, should be n minus 1. That's still wrong. 1, 2. Okay, back to this. Alright, we're gonna say here. What are we gonna say? S can be. You have to keep at least J. 0. If I less than J. You have to subtract that back, because that has to go in the previous one. Alright, this should be it. But it's still gonna fail on this next one, right? It's gonna fail on this. What we need to do is to n and make sure the nth value is just 0. Let's do a of n equals 1. Why? Okay. Never mind. Max 0. Yes. This should be 1. Please say I did this right. How did I take this long? And watch. It's gonna get wrong answer test 6. Or test 3. Finally. Well, alright. It wasn't an awful problem, but I was being really dumb on it. Multiplicity. You're given an integer array, blah blah blah. The array B is a subsequence, blah blah blah. Good. And BI is divisible by I. Okay. Alright, just... So the first element must be divisible by 1, the second divisible by 2, etc. Then we notice that the elements can only go up to 10 to the 6th. Interesting. first glance, this looks kind of hard for a Div 2C. Well, I'm sure it's not actually that hard. Alright, so imagine we had different layers of so for every index we had a layer. This is where the number of ways to end at that index where it's the first one chosen. It's the number of ways where it's the second one chosen, etc. So of course we can only take update it from before if the index I is divisible. The element here is divisible by the row. So that means it'll basically be like a... So now we can just store like the number of ways here, like in a bit or a Fenwick tree, whatever you want to call it. So then now we can basically just go backwards. We can store for each level which elements are going to be updated in each level, and then go backwards. Does that make sense? Hopefully that makes sense. Makes sense to me, at least. Alright. Well, we can then basically just solve each level. Why a Fenwick tree? We can solve each level with like 2 pointers. That would be better. Okay. I think this works. Create a new page. Alright, it'll make more sense what I'm doing in the code. So first off, set max. No, I need to set. Well, no, it should just be this. And then I need a vector. So now we basically need to do, as we're reading in integers, we need to get the integer, then we need to see every value that they're divisible by. What's the maximum amount of divisors? For up to a of I, it's around cube root of n. Actually, let's just add this. If not percent j, so if x is divisible by j, v of j if at x. If not, and not. Wait, you're stupid. This should be on the outside. So if not x% j, and then if j times j is not equal to n, we do v of n over j. Alright, basically this is putting in each index all of the indices such that a of I is equal to is divisible by this. Hopefully that makes sense. Now we're also going to add a dp here. basically we just go here. All we have to put is actually, no, let's make this one mix. And then we say v of 0 dot push 0. Okay. So then now we say we're basically gonna do a 2-pointer at each level. So imagine like in this level, this index, and this index are marked. And at this level, like this index, and this index are marked. Well, we iterate along this level, and we have a second pointer down at this level. And we say, and we need to add to the sum that transitions to here all the values that are before it. So like, we move the pointer up until it's greater than or equal to the current value on the level above, and then we add the sum, the whole prefix sum, up to there. Hopefully you see why. Like, this is the DP of the number of levels that end at this index that have used this many values. And then you can see, because we're only here to like find the factors, only iterating through square root of n, there will be at most, the sum of the numbers in all the levels will be at most like on square root n. It'll actually be closer to on cube root n or something. So it should work in time, hopefully. Alright, what was so now we need to do dp I.desize size. Oh wait, dp of 0 should be 0. Now we say, oh, we need an answer. Wow. What's it for? L is less than b of I minus 1. And b of I minus 1 L is less than b of I j L plus plus. And we do x plus equals dp of I minus 1 L. So here you can see that I'm doing the 2-pointer thing to get the sum of the values less than it. And now we say dp of I j is equal to x. Do we need the x value? That makes it easier. Alright, sure. Now, oh yeah, and then we have to do plus equals x. Oops, I forgot to print out the result. That was dumb. That's something. I minus 1 L. E of j. Listen, it shouldn't be less than or equal to n, less than or equal to x. Not that that should really affect it. Well, that also looks like a problem. for some reason, nothing is going in. Why? Well, probably because I forgot to delete it, man. So many dumb mistakes. Also, this doesn't need to be one. Why is one being printed twice? That is not very ideal. Let's see. Not equal to X. Why did I put N here all the time? And this one should be 15. Yeah. Oh yeah, and just to be clear, you can see that each level is a linear in the number of elements and the sum of the level and the level below. Because the pointer, both pointers on the level and the level below, each only iterate through the elements of that level once. Which is why the sum of the complexity will be the sum of the elements in each level, which, like I said earlier, should be around n cube root n or something. Well, n cube root of the max value. Anyway, let's see. Hopefully this works. Well, it looked like it's doing good. And accepted. Well, that went a lot better than B. Very nice. TV shows. Why is BenQ starting? Time split into equal parts, 12 minutes. I show Li to Ri. You need a TV to watch it. Watch a TV show. Can't watch 2 TV shows which air at the same time. So possibly you'll need multiple TVs in some minutes. For example, segment Li. Alright. Yeah, okay. There's a TV rental shop. Find the minimum possible cost to view all the shows. Oh wait, what if the shows intersect? Interesting. Oh, you can get multiple TVs. Okay, I think I get it. Not that. Go away. So for this problem, we have different intervals. It looks something like this. Now we're allowed to rent a TV. How are we gonna denote the TV? We're allowed to rent a TV, so it can cover some amount of time. Like here. But this TV can be used to cover this interval and this interval. But it can only cover disjoint intervals. So we need like to get multiple TVs. And each interval cost has a set price X, well, each TB interval has a set price x, then you have to add y times the length of the interval. Alright. What are my ideas on this? Well, obviously, the end of an interval that we have a TB should end on a time that we, you know, by one of these things. That, like, such that it covers this. However, it can also extend backward to cover another interval. Okay. We have to deal with overlapping intervals. We could have an interval here too. It's completely inside. This is a bit tricky. Not having any immediate ideas. Obviously, it's going to be some sort of dynamic programming, DP, whatever. Will it be DP? That was creepy. There'll be some DP based on the... I'm guessing that depends on the endpoint of the intervals given. Because each of our TB, like I said before, it should end at the same time as an interval, and then it should correspond to at least the final interval it covers. But then, there may be other TBs that are like starting here, right? So like, how do you deal with the TP state where you're adding... Oh wait. This is easy. No. All you need is what we want somehow is to have a DP state where we can just add the previous one, but also account for having an open interval, if we can say is like a... So we don't have to start a new one, which is like a... just having a... Let's say this is the index, what's the position? Be like a negative y times p, so then we could just add y times q here, if this q is the position here, to add the distance that corresponds to the length, the cost that corresponds to the length, rather. But of course, if we have an open interval that's open inside of it, then we'll be having overlapping intervals in the same TB. We don't want that. So can we have like a, somehow have a segment tree correspond to all the intervals that are ending that have an open interval? Well, you can have multiple open intervals too. Say all the multiple open intervals are coming before this point. Well, similarly, how do you know if you've what if you closed off all the open intervals? Oh, wait. Should we ever have more than one open interval? Yeah, I think so. It's like, what if we had another interval up here? We wanted an open interval coming out of here, and one coming out of here, and one coming out of here. How would we deal with that? Alright, I'm thinking dealing with like an open close isn't gonna work in this case. Well, we want... what do we want? What do we want to do? It's definitely a pretty tricky problem. Can't say I like the new album very much. Oh, that's alright. That's just not really my thing. Anyway, focusing on this. Audience show, okay, cannot be watched simultaneously, okay. So think about the current interval. Which, would we attach to any besides the previous one? Probably not, right? Like the closest one that's beside it. So what if we just greedily said, we like sort the intervals by the right endpoint. Then we just say for the current one, the cost is the min of, we add a new TV that's just for this interval. Or we look at the closest interval that's closest to it and add the distance from there to here. Would that work? That might work. Why would it not work? Is there any counter case? Well, what if that cost was already added to someone else? Alright, wait. We're gonna take a new perspective to the problem. first off, we know that the distance, the cost between, like, of the length of the interval will always be used. Our only goal is that we want to decrease the amount of distinct TVs we use by possibly combining two intervals that are disjoint. So imagine each interval has each interval's endpoint can only connect to one other interval. What's the cost? The cost is the distance between where it connects to y times d minus x, because when you connect them, then you're using 1 less x, but you're adding the distance for that. And each endpoint of one interval can only connect to the endpoint of one other interval, right? Because you're only having one TV that is being that one's being watched by. So it feels like a maximum matching problem, actually. Like, imagine n was only smaller. Then it'd be like a bipartite matching, where like matching this guy to here. Well, except each of the matchings have cost. And you want the maximum matching. Okay. Wait, let's see, maximum matching. Each right endpoint, each goes to a left endpoint that's after it. You can think of each one as a node. The right are over here and the left over here. They have an edge of this cost, and you want to pump the maximum flow through it. Flow your boat. Wait, why does... Well, you can't just make a flow network. Because it's like a min cost max flow. But obviously, this is just a div too deep. So we're not going to be doing min cost max flow. So we need some sort of greedy algorithm probably that can do this instead. Flow your boat gently down the stream. Imagine you have two intervals that are like here and here, and then you have two intervals, one here and then one here. Obviously this one is closest to both of them, but you can't match both of them to here. You can match one to here though, and one to here. Well, what do we notice about this setup? Well, of course, so we want to match the two that are closest together first, and then update which one is closest that is left. I guess, something like that. So I guess, alright, what if we greedily did this? First we had H1 match to where it's closest, okay? And then now, we match the pair with smallest distance greedily. Then, for all the ones that were like matched, to one of those two in the pair, we rematch them. If we just greedily kept doing that, would that work? I'm not too sure. But it's an interesting idea, I think. It's like kinda like minimum spanning tree, but like not really. Well, is it like how could you prove that this is optimal? Well, why would you ever not pair up the two that are closest in the graph? Because that would mean those two are the closest to each other for all of the intervals that are left. So then you would be, if you match like a different one to here, then you'd have to match this one to one that's farther away as well. And of course, that would always be worse, right? You think of any way where that's better? No. Alright, I'm pretty sure this idea is right. But I'm gonna read problem E first, if I don't figure that out. And like, I don't know. How much long do I have left? If I don't figure that out in like 7 minutes, I'll try my idea for D. If that's the right idea, that's a pretty cool problem. In cities, 2 candidates are fighting for the post of the president. Typical politics. Alright, a tree. And then two important nodes. City has a potential. Okay. Exports in the subtree. Vacate the city of his tree. I feel like, why do I feel like I've seen this before? Alright, oh no, let's draw an example. I don't think I've seen this exact problem, but it reminds me, I did this contest where it was like you had like 2 trees, and it was like something along the lines of connecting subtrees. Then it was a flow problem. But I don't think it was the same as this. And then the contest that I saw it in stole that from a Romanian Olympiad contest. But I never bothered to understand the solution. Sad. So we have like Right, so we have two nodes denoted as capital. Capital. Like this. What are these things for? I don't know. BORONG. This guy will have commands going outward. Alright, that means there can only be exports in this subtree. Could also be. Alright, first off, let's think about solving this for a single root, right? What's the solution for a single root? Well, it's not too hard. It's basically a set merging problem. Or like a... we say, for all subtrees, we like mark the node as bringing in the revenue originally, because all the revenue is positive. So then we of course want to turn it on if we can. But whenever we're at a subtree with a constraint, then we just delete the smallest values from the set until the tree has until that subtree only has x turned on, and then we keep repeating that. If there's less than x in the set of the subtree, and then we know that it fails. Now we need to come up with some idea for what to do. What was I thinking? Oh yeah, for what to do with two root stuff. The two roots constraint is not trivial. I'm feeling pretty confident in my D idea now. After like looking at this, right? Why would you not connect the two that are close to each other? It feels like minimum spanning tree, but I don't know like exactly how to do like a bijection or whatever from this problem to minimum spanning tree. But I feel like it's the same proof where like you can see if you were to ever match this one and this one to something else, it'd always be better to like just you can think of them as like it'd be better to replace their matchings like this. It'd either be the same or better. Well, it should be the same, I guess. Because... No, it should be better. This interval will be added twice. The other stuff is added twice. Added once, as opposed to adding this. Yeah, it should be the same if you swap them. Alright, I'm feeling pretty confident in that idea. Going back to this real quick. Where are we at? Okay, yeah. My penalty was not good. Alright, just think about this a little bit more. So we have like our set merging idea. Is there a better way to think of it? Not really, I guess. So imagine we root the tree at one of them and start the DP. What would it look like? Well, for all the... we could just add the constraints just the same in the subtree of the other root, right? However, then there could be constraints. Any So which constraints are actually a problem then? If they're also like could be contained in a subtree, then they're just the same. The problem is, let's say the subtree in question is one of its ancestors. Then it will like go all the way up like this. And you have to say, in this subtree, there can be at most, there have to be exactly this many. Well, we can see that that's like the inverse of a subtree by the other root, right? Is there a way to, that we could just like change the constraint so it just works like that? Let's see. Change the constraint. Another one. So we'll have like the root, we'll have one of the capitals be the root, but then we go down, each of these has a subtree. But the problem is then the second capital, which will have its own subtree, it will have constraints like this, right? Like any constraint that's inside of here is okay. It's only the constraints that are along the path from here to here, because then they don't correspond to a subtree. We can think of it, if we wanted to think of it more symmetrically, we could say basically any subtree for either of them that's not on the path between them can just be treated as a normal subtree. So that now, so let's say you solve for each of those separately, right? With this sort of set merging thing. At the end, you'll have a set on each node. A set of values you can have on each node. Right? Right, yeah. I think we can all agree. So now you'll basically have like a line with multiple sets on the line, and you can choose some of the values from each of the sets. Wait. Am I thinking about this problem correctly at all? No. Okay, remember, it's not like at most k. It's for a for a subtree, you have to take exactly k. Right. So that'll like a. So then you have to take the best in the subtree and then delete that set, and then say for all values above it, you've already taken x, so you can update like how many they have. So now you're left with some values in each of these nodes that you can pick. And you have some, and they're in a line. And you have some constraints where you can think of as divisions. At the left, you can pick at most, you have to pick exactly this many. Right. Sure. Constraints on the pick left, you have to pick exactly this many. And on the right, you'll have to pick exactly this many. Like, imagine we only had 2 constraints. You have to pick at least 5 this way, and then at least 7 this way. But then we had like a bunch of good ones here that we wanted to use for this constraint. Like, we could have, we could be picking 5 and 7 like this, or we could be picking them all in between, where it's just like, well, we could have 5 here and then 2 here. How do you deal with those different ways of thinking? Well, oh wait, n is less than 500? Oh, n is less than or equal to 500. That changes a lot. Alright. That means we can do some sort of DP. But I'm still not. I'm guessing instead we're doing like a DP. We don't even have to treat these as separate cases. We're doing a DP. It's like a DP of how node number you have selected, and how many you're selecting above the subtree, something like that. I'm not entirely sure. We'll come back to this though. First, let's code this idea. It's not super easy to code, but it shouldn't be, like, impossible. And what are x? Oh. Let's see. Alright, we can treat the L and R as completely separate, right? Like, we don't even have to care that they're part of the same interval. I think so. That makes implementation a bit nicer. Let's see, we need a, what do we need? We need like a set to do lower bound. When we're doing updates. Can we just use a segment tree? It's easier to use a set. We could do some segment tree thing, but this is easier. Set here. Let's call this set. How much time do we have? 44 minutes. Alright. Well, surely we can at least get D. I don't know about getting E. Oh, wait. According to this, F is easier than E. So maybe we should be trying that next after we get D. Okay. Let me change. What do we want to do is, let's just do this. What was I doing? Alright, each value needs to store which one's closest to it, and all values that it is the closest one to. Alright, let's see. Let's do instead. Alright, let's do something like this. Now we get through. This should be, SA should be greater than SA.insert negative 0x. What was I getting? Alright, it's B of N. Alright, this just makes it so we don't have to test, like, does that value exist? Alright, I remember. I needed a queue. We need a priority queue to, like, hold all the, like, distances. So here's a priority queue. Create a queue. Now there should be PII. So first off, we'll put in all the initial distances. So we'll do FA. We're gonna need to do it multiple times. I'll show you what I mean. It's the null not. Alright, int x, now we say if bb of y, so then this array, these two arrays are, is this value already picked? Because if so, we need to just recalculate it. So if bb of y not bb if not. Alright, these are the three cases that matter. So if let's put this at the topic. Okay, so then here's when they've both not been selected yet. We can actually get rid of this. Just nice. Okay. Not v of x and not bb of y. We do. Oh wait, this should be pairs, right? We need to do sa dot erase x, b dot erase b of y, y. These need to both be turned on. If x is n, well, we need to say that actually, no, we'll just get rid of it. Okay, I think we have it. If we did this, alright, we need to also remember to add. So what do we add here? Remember, we add at the beginning, then n plus I times a. We have to add this at the beginning, because we're assuming there's one TV for each interval at first, but then we're combining TVs here. Wait, let's make this z. And red is equal to z. Now, we're gonna, at some point of time, an interval may be like negative cost. Actually, wait, no. We'll just only put intervals in the priority queue if they have positive cost. That works. So we can just get rid of this. and call this red. And here we need to do fa of x, and here we do f of y. Because this means that we need to instead find the new interval. This should be right. Oh wait, I forgot to update this. And then ret minus x plus. Oh wait, this should be. A of x minus b of y. Now here, we're subtracting x because we are getting rid of one TV because we're combining two intervals. And then we're also subtracting a of x minus b of y times k. Am I doing this right? Because a of x will be to the left of b of y. To the right, to the right. This should be right. Okay, all we have to do now is make the function fa and fb. They're almost identical. Alright, fa. Auto t is equal to no, I was already fixed. SB dot lower down to upper. What? You have to do what? Do they intersect if they touch at an endpoint? I don't know. Yeah, I guess. Because otherwise you'd put this with this one. So that means 1, 2, and 2, 4 are counted as intersecting. 1, 2. Yeah, okay, whatever. Oh, well, you're thinking it's taking like 1 to 2 and 2 to whatever. Okay. SB, the upper bound. What was I doing? A of x, comma 0. If IT is not equal to SB.n, Z is equal to A of x minus a of s, x plus tf. Alright, this should be this. And then Z 0. Push. Wait, so we do want the greatest values. So we're subtracting. Z, comma, X, comma, something like this. Now we can basically copy this, except for here. We're doing say from E of X, F, say to end, flip these around. B of X, Q dot push, S, comma, X. This should be right, I think. Let's see if it works. Will this work? Nope. Why? Why? X, 1. Let's see what is going on here. 0 and 1. 2 and 4. 3. 0, 1, 2, 3, 4, 4. 4 is going to 3. This is going to here. That's okay. This is going to here. That's okay. 1 and 2. Okay, so my program is saying these two should be combined. When it should not be. Why is this being fixed? Well, that's even worse. It's combining these and these. Minus equals M. Well, it's adding this value, subtracting M. So we just need to change these to subtraction and it should all work out. Okay, that looks good. Next. Good. Next. Oh, I need to be careful here about storing long. Why am I getting this? Wait, I thought you couldn't combine these. Oh. Wait. why is the answer being printed? Modulo 10 to the 9th plus 7. That's stupid. Because like if it's a maximum, if it's minimizing, I need to keep 1, 2, 3, 4, 5, 6. Okay. That's stupid, but whatever. Maybe they're like trying to disguise the answer or something? I don't know. Let's see, will this work? Please work. Oh, does test 10? Come on. Shouldn't be any overflow, right? Why are we not getting... Of course. Oh, we're doing better than Alex. This doesn't overflow, right? So at most 10 to the 9th. So then, the maximum value it can be is the difference in here, 10 to the 9th, times y, just like 10 to the 18th, plus 10 to the 5th times 10 to the 9th, which is... I feel like our idea is right? Upper bound b of x and lower bound. It should be right. What are we doing wrong? I don't know. Dang. What are we doing wrong? Be preferable to figure that out. Overflow, overflow. I don't see anywhere where there'd be overflow. A of I is supposed to find one before A of I is supposed to find one after. Well, this ain't good. I have no clue what I'm doing wrong. I thought my idea was right. Stupid eczema. Eczema's a pain. I don't even have it that bad. I'm not sure what exactly I'm doing wrong. I feel like my idea is right. I'm getting to test 10. And they're getting only to test 7. Also, if both Alex and I are only getting up to C, this must be hard. Well, it shouldn't be that hard though. Come on. Minimum cost view shows. Why is it taking modulo? Alright, let's go back to politics real quick. So it'd be helpful if we had a DP. worry about from here to here. How many have we chosen? How many are we going to choose outside the subtree? How many are we choosing? How many are we going to choose outside the subtree? We need to satisfy the constraint. Because the multiple intervals, like if we have like two things like this, you have one here and one here, that basically we also know exactly how many we need here just by like subtracting two amounts. So we know that. Well, no, because remember, we could have some here, and some in here, where they satisfy both of them. Well, no. What are we talking about here? Oh, we were talking about the cases when there's one here and one here. Well, once you get it up to here, you basically have intervals. Let's say you need this many from here, this many from here, etc. How many have we taken? How many will we take? Can we do it all in one DP? Well, like if we do, we need how many have we taken? How many will we take, right? And that doesn't really work in time, because that would be like, you know, combining subtrees. That's already like O(n) squared. Then combining these, that'd be like, well, what would that be like? Well, they have to be the same, right? I guess it's O(n) cubed. Maybe this DP would work. Well, of course there's not going to be enough space for 500 cubed, right? What is 500 cubed? It's like 125 million. Oops. Okay. 500 cubed? Yeah, 125. Alright, so I think it's best, like I said before, do the greedy with the set up to here, and then we have some values we can pick at each point. And then now we can do some DP just on a line. What's a DP on a line? Well, how is a line easier than a tree? Because we don't have to combine, right? And then we can only hold, we can do like DP of XY. So we'd only have ON squared memory, ON cubed DP. Okay. Okay, I think this would work. So basically, you use the set, the greedy set solution for all the subtrees not on the line. So then this will add some values to the solution, but then they'll reach here. But then you'll have some extra values that don't have to be put in any of the subtrees below. And you'll say that each of these can have so many values of the ones remaining. So now you do a DP where it's like, how many have you taken? How many do you need to take? So then you need to make sure at each time you reach an endpoint that's like this way, you have to make sure that the DP of X matches up, and when you reach a Y, you have to make sure the Y matches up. Alright, well, I don't think I can code that in time though. Well, what? 5 minutes left. Okay. Bruh. Alright, if he got it, then surely I can. What am I doing wrong here? Alright, come on, 5 minutes. So we're reading in the intervals, putting them in the sets. There shouldn't be overflow, because this A and BI are at most 10 to the 9th. Now you do. And you have to add the value for that interval. Now for each interval, each endpoint, you have to find the other endpoint that it matches to, where the BI goes to like one greater than it. if I goes to 1 greater than it. You should be able to just do this. Doing this correct. Speed, upper band. TFS, X. This is BFX, BFX. Okay, what am I doing wrong? This looks alright to me. Why? Alright, I'm gonna go for desperate times call for. Desperate times call for desperate measures, as they say. Maybe I somehow had overflow, because I can't imagine anything else is wrong. Bug. Of course not. What else did I do wrong? I think my idea is right. Right. Should always pick the two that are closest together. We never do. This one that is farther than this. Would we? Oh, think about this. Where'd my pen go? Here it is. What about a case like this? Is it ever optimal to do? No, it always ends up the same, right? If you have two choices, which goes here, you should choose the one that's closer. Because the one, if the farther one also matches up, so then it'd always be better to do that. Should be right. Well, that's disappointing. That did not look like that was not the Div 2 redemption I wanted. But the problems were pretty good. They're pretty good problems for Div 2. What was F? Curiosity. Tree, no cycles. Tree is called K-area if either vertex. So leaf has exactly 12 divisions, okay. Perfect K-area tree. Node with label B lies on the path from A to C. Okay, and you have to print the root. Interesting. Well, I'm gonna look at the test case, see if that helps me figure out why this did not work, because I'm pretty unhappy this did not work. Alright, let's submit it again. What? Oh, you've got to be. What was it? How? What was the overflow? Long? A of I, B of I? How was there overflow there? I said, is there overflow multiple times? Look. K is a long. Correct? You can see right here, K is a long. K is at most 10 to the 9th. 10 to the 9th times 10 to the 9th is 10 to the 18th. B of I minus A of I. Wait. You have 10 to the 9th times 10 to the 9th times 10 to the 5th, you idiot. Okay. But why is that even a thing? Like, really? Come on. There should be in 128. You can't see out 128 bit. That's so stupid. Oh, what is it? What is it? What in 128? That is so stupid. Why? Why do they do this to me? Oh, wait. Actually, you don't need it in 128. Because all the sub things. This equals 1 times. Now I see. Amazing. We checked for overflow multiple times, and we're still too stupid to see it. Okay, I like the problem, but why? Why were the constraints like that? That was so stupid. Pretty sure idea for E was right. Let me see. Can I think of an idea for lost root real quick? K-ary tree. K-ary tree. Turns out B lies on the path from A to C. 60 times M queries. Well, let's see. Think about the diameter of the tree. The diameter will always go through the root, right? So what if you found the diameter? What's the diameter algorithm, right? It's like, we could basically say, well, let's root the tree at the given index, right? And what do we ask? we'll pick a random vertex, see which are in the subtree. Can we just do this with a randomized algorithm? Hold on. I want to see the tutorials and see if my ideas are right. Oh hey, remember I said this was going to be some flow thing? Okay, I think this is the same. Yeah, you know how I said a while ago, you could do this with like that Romanian OI one. I think that is the same as this, even though I did not think that was actually going to be this. I still think though, it can be done in just and with just DP. But let me read this. We should decay the left layer, capacity. Oh yeah. Alright, sure. That one's also. So basically what they're saying is, you create two trees. One with like each of them as a root, right? So basically, you could solve this problem even if the trees weren't the same. Wait, are the trees the same? Oh wait. You idiot. Why didn't you read the problem? They are two distinct trees. Okay, so this is like an exact copy. I was thinking of the wrong problem the whole time. Anyway, this is like an exact copy of the one that I was like mentioning from Romanian OI. But yeah, basically, you create a flow where everything, where there's like a... You see how many of the previous nodes in the subtree have to be cut off. And then, Wait. Hold on. Do I understand? Okay. From the source to node K in the left layer, cost 0, capacity X, I'm too lazy to read this. But, okay, I've seen this exact problem at least 3 times now. This is the 3rd time I've seen it, and yet I was able to solve it none of the times. Amazing. So I should probably actually, like, read the solution carefully. Lost root, is it a randomized algorithm? It is. Yeah, I've seen this. I've seen a problem like this before. It was on APIO something. And then it was also on when I was looking for the solution, I saw it was also from, what's it called? Do I have it saved? Not this. CS Academy. That. I don't use that very often. I remember someone saying that there was the same problem as CS again. So, 2 copied problems. Anyone else say that? Well, it's also from 3 years ago, so maybe they were the original. Oh no. Anyway, that was sad. How did you not solve this? Ugh. Stupid overflow. Oh, that's all for today. Adios.